Okay.
Okay, sir.
Yeah. So now about the hold time contamination delays. What would you say about this? We already discussed this is the flops.
The contamination delay should be greater than
Contamination delay should be greater than T hold minus tcpq.
Yes, sir.
Now over here we assume that both the clocks arrived at the same time. There would be skew there, and then we will have to consider skew also, which we did in the last class already.
Yes, sir.
Okay. What about min delay in two-phase latches? Min delay in two-phase latches. We would want that the phi1 triggered output should reach L2 after the hold time requirement has been met. Is this clear?
Yes.
So what are we saying? Phi1 triggered output will first have this non-overlap window there. Then there will be tcpq, and then there will be contamination delay of the combinational logic. This should be.
Sir, it has the same before, sir, but only T non-overlap. I think that should get added.
Yes, this has got added. So what has happened is that this contamination delay constraints, if you can give more overlaps, then contamination delay can be still smaller. Is this thing clear for the two-phase latches?
So why the phi1 is after the phi2? This window shouldn't be before. I mean, because
It will come after also, no? How
yes,
will
sir.
I consider the hold time requirement of L2? Because L2 sampling edge closed, now I want input of L2 to be stable. What will spoil the input of input of L2? The rising edge of phi1. So the rising edge of phi1 that comes after falling edge of phi2 is what I'm interested in, is it not?
Sir, but after the falling edge of phi2, it will stop sampling, right?
But there is a hold time requirement.
Okay, yes. Yes. Okay.
That is what I am interested in.
Sir, for building a faster circuit, I will like to increase the non-overlap period, right?
Non-overlap is a dead period. Nothing is happening there. Non-overlap is a dead period. No sampling could be happening. You may actually be losing data because of non-overlap. The non-overlap benefit is that your hold time failures will not happen.
Yes, sir. But I can have lower contamination delays that way.
Yes, because you have more margins. There is there's increased non-overlap duration. Okay. Okay. Now we come to min delay for the pulse latches. Here, what is the requirement?
T hold minus clock to Q plus the pulse width that is there.
Yes. Hai. So over here, pulse width gets added. Because for the entire duration of the pulse width, there should be no change in the input over here. Are you able to see this?
So please explain the pulse width part.
So which is the sampling edge?
Negative edge.
So you triggered the data from here.
Yes, sir.
and you want to define the hold time from here, the negative
That's
edge.
why we are doing T plus TP. Okay. Yeah, got that.
So, sir, hello.
Yeah.
So we also talked about this in the previous class also. So this hold always would be higher. So how would we justify it? How will I justify using a pulse latch before a flip flop at anywhere if I use?
We'll see. What
Okay,
is the
time
overhead?
bar.
So you have to look at other things also. What is the sequencing overhead of a pulse latch? As we come to time borrowing, we will see what is the benefit or the loss there. There are so many aspects.
Yes,
The
sir.
most important aspect is pulse latch is much denser than a flip flop. It has much lesser number of devices than a flip flop.
Yeah.
So it consumes much lesser area.
Yes,
Lesser
sir.
area means faster also. Lesser leakage also.
Area is gold.
So if everything else is equivalent, I may still want to use pulse latch.
Yes, sir. Yes, sir.
Shakti, you have a question?
Yes, sir. So, sir, this pulsed clock is the internal clock of pulse latch. So, I have heard that we characterize setup and hold time at the original clock of the system. So,
Yeah.
So why are we doing here at the
So in
pulsed
this particular
clock?
system, this clock is in the shape of a pulse. In this particular system that we are considering, clock is coming as a pulse only. The one that you have, that you are referring to over there, we are generating the pulse from the clock internally, because that is how typical systems are. See, in a typical system, let us say, in a typical system, when you have to design an ARM core or anything, you cannot really have such short pulses. However, if you're designing a very specific system where you're using only latches all over the place, and pulse latches are that, then you may say that, okay, instead of having a pulse generator in every latch, I would rather use a pulsed clock. That is what we're talking about over here. Okay?
Okay.
Yeah. Raghav?
Sir, can you just, I'm not able to get the transitioning here, sir. Like, for example, I'm consider for the whole time, I will be consider transitioning the same transitioning at the L2 latch, right?
Yeah.
So, sir, this
So for
plus,
L2, what is the requirement?
so that after the falling edge, my data should be stable for T hold.
Yeah. So from, let us say it got triggered from the rising edge of L1, of clock at L1.
Yes, sir.
So tcpq
Yes.
plus tcd of the combination logic.
Yes, sir.
Should be greater than
The T hold.
T hold plus, where is this T hold coming from? Not the rising edge of 5p, but from the falling edge of 5p. So pulse width. The sampling edge for a latch is falling edge.
Yes, sir.
That is where tpw gets added.
Okay, right.
Okay, Gagandeep?
Right.
Sir, here the hold requirement is more tight and setup would be relaxed, right?
Yes.
So, sir, is building this type of system not more risky because you cannot recover hold once failed?
Yes.
They are more critical.
Yes. That is why they're not very commonly used, but they are still used. As we just discussed, there is a benefit in area, there's a benefit in overall leakage, everything, there's a benefit. So, okay, we take some risk. We'll sign off more carefully.
Sir, this, I mean, if you try to decrease the pulse width to get a better hold requirement, so in that case, you will be kind of sending very, very small spikes of
Yes, clock. Yes, that's a bigger challenge. What is the smallest clock pulse that you can send?
That depends upon the setup as well.
Why?
As I decrease the pulse width, so setup will also be pushed back and back. So it will.
The setup, see, as I reduce the pulse width, the system will become more and more like a flop.
Yes, sir.
So what's the big deal? I'm getting a flop kind of functionality at half the area.
But sending these pulses to distance would be like it will
That is
die
the
off.
challenge. That is the challenge. That I agree. I'm not saying it is easy, but there's a benefit, a clear benefit there. Because the area is lesser, this RC delay is due to which I cannot send signals or short pulses to long distances. That also reduces.
Yes.
Hai Raghav, you have a question?
Sir, I just saw my hand.
Okay. Animesh?
So, sir, the pulse width also has to be greater than the C2Q delay.
You really need that?
So, because reducing the pulse width a lot smaller wasn't making the system work correctly.
Yeah. So, is there a link to CCQ? That is what my question is. Or is there a link, or do you need a minimum pulse width because of many other reasons? Or is it only CCQ?
There can be many there, but I noticed this, that CQ was always smaller than the minimum pulse width, whatever they were using. So the pulse width was greater than CQ.
But
I'm not sure about this, but
that is a representation they have made in the diagrams. Don't read too much into it. These diagrams are not to time scale.
yes, sir.
Okay. So now let's look at skew. What happens when skew is added? Flip-flops we've already done. So skew gets added as overhead there. Simple. For whole time, again, you will have to assume that skew is to be taken care of in the contamination delay thing.
Sir, upper one is negative skew and lower one is positive skew, right?
In both the cases, we have said that skew is positive. We are, as of now, in this particular equation, keeping skew as positive. If the skew is negative, the value of t skew will come negative automatically.
Okay.
Okay.
If you don't take that sign, then we'll have to.
Yeah.